Scientists finally found a new way human can travel faster than light. Scientists have finally found a way to travel faster than light. What is it, and how will it happen? Let us look at claims by scientists. Hello friends, and welcome back to Space Webb. So today, we are going to discuss the recent claim made by scientists. They claim that they have found a way to travel faster than light. If it were possible, it would be the biggest discovery of the century. Let us look at what they have to claim. But before that, don't forget to subscribe to our channel if you haven't already done so, and hit the bell icon. So, what are we waiting for? Let's start with our topic. Scientists are trying to find a way to travel faster than light. According to the theory of relativity, if humans can travel faster than light, they can actually do time traveling. As we all know, scientists have been trying for a long time to do these things. Recent studies show that we are quite near to success. But how is it possible now? Let us try to understand. The star PROXIMA Centauri is the one that is closest to the Earth. It is approximately 4.25 light years away, which is equal to around 25 trillion miles. The Parker Solar Probe, which is already in space, will become the fastest spacecraft ever when it reaches its peak speed of 450,000 miles or 724,000 kilometers per hour. At such speed, traveling from Los Angeles to New York City would take just 20 seconds, but it would take the solar probe almost 6,633 years to get to the solar system that is closest to Earth's. It will be necessary for humanity to achieve speeds greater than those of light if it ever hopes to make interstellar travel convenient. However, as of right now, traveling faster than the speed of light is only possible in science fiction. One of the world's leading scientists has said that the concept of spacecraft capable of traveling at warp speed is not completely out of the realm of possibility. Dr. Eric Lentz, a physicist, recently published a study in which he presented a method by which a rocket might hypothetically travel faster than the speed of light, which is equivalent to approximately 186,000 miles per second. It would only take a few years for astronauts to travel to other star systems at such speed, which would make it possible for humanity to colonize planets that are very far away. With the rocket technology that we have now, it would take about 6,300 years to go to Proxima Centauri, the star that is the nearest to our Sun. There have been previous discussions about so-called warp drives. However, most of these discussions rely on theoretical systems that violate the rules of physics. Because Einstein's general theory of relativity states that it is physically impossible for anything to travel faster than the speed of light, this is the reason why it cannot happen. According to Dr. Lentz, a scientist at Göttingen University in Germany, his hypothetical warp drive would be able to function within the constraints imposed by the laws of physics. This theory circumvents the issue that other theories, such as those based on negative energy and other exotic concepts, have by proposing a novel theoretical particle. According to a news release issued by Göttingen University, these ultra-fast solitons can travel at any speed while yet adhering to the laws of physics. A compact wave that behaves like a particle while preserving its shape and moving at a constant velocity is called a soliton. This type of wave is also referred to as a warp bubble. Dr. Lentz claimed that he came up with his notion after doing an analysis of the previously conducted research and identifying holes in the findings of earlier warp drive experiments. He believes that solitons are capable of traveling at speeds greater than the speed of light and creating a conducting plasma and classical electromagnetic fields. Both of these ideas are compliant with Einstein's theory of relativity and are comprehended within the framework of conventional physics. His warp drive raises the tantalizing prospect of traveling faster than the speed of light. Nevertheless, at this point, it is still very much in the conceptual stage. The device would need to use a massive quantity of power, which is not feasible with today's technology. Albert Einstein's general relativity theory is the foundation of modern physics knowledge of space-time. According to general relativity, nothing can travel faster than the speed of light in the universe. Mass and energy can also cause space-time to distort around massive objects, such as stars and black holes. Gravity is the curvature of space-time, which is why many space explorers are afraid of falling into or being stuck in a gravity well. John Campbell and Isaac Asimov, pioneers of science fiction, regarded this warping as a chance to go faster than the law. Wouldn't it be cool if a spaceship could shrink the volume of space in front of it while simultaneously increasing it in the back? The warp drive from Star Trek is based on this concept. Physicist Miguel Alcubierre, a Mexican theoretical physicist, demonstrated in 1994 that it was mathematically conceivable to compress space-time in front of a spaceship while expanding it behind. Then, what does it mean to say that? Imagine a distance of 10 meters between two places, or about 33 feet. It would take 10 seconds to get from point A to point B if you could move at the speed of 1 meter per second. However, if the distance between you and point B could be reduced to only 1 meter, that would be ideal. You could get from point A to point B in about a second if you were traveling through space-time at a speed of 1 meter per second. As long as you're not traveling faster than the speed of light in the area where you're looking, this strategy should be consistent with general relativity. It was shown that the warp drive from Star Trek was theoretically viable by Alcubierre. We're going to Proxima Centauri, aren't we? To compress space-time, Alcubierre's method required negative energy or negative mass. Unfortunately, this was an issue. The Alcubierre warp drive would function by first generating a bubble of spacetime that was flat around the spaceship and then curving spacetime around the bubble to shorten the distances between locations. For the warp drive to function, either the hypothetical substance known as negative mass or an energy density ring must be present and in sufficient quantity. Since physicists have never witnessed negative mass, negative energy is the only other possibility that can be considered at this time. A significant quantity of mass would need to be utilized by a warp drive to bring about an unbalance between the number of particles and antiparticles to generate negative energy. For instance, if an electron and an anti-electron were to show up close to the warp drive, one of the particles would be captured by the mass, which would lead to an imbalance in the system. Due to this energy imbalance, there is a negative density of energy. This negative energy would be used by the warp drive that Alcubierre possesses to produce the space-time bubble. However, for a warp drive to generate sufficient amounts of negative energy, a substantial amount of matter is required. According to Alcubierre's calculations, a warp drive with a bubble measuring 100 meters in diameter would require the mass of the entire observable universe. Chris Vandenbroek, a physicist, demonstrated in 1999 that increasing the volume contained within the bubble while maintaining the same surface area would drastically lower the amount of energy required, bringing it down to just about the same level as the mass of the Sun. A considerable advance, but it is still a long way beyond anything that is even remotely possible in practice. Bobrick and Martyr concluded that they might eliminate the requirement to make use of negative energy if they altered space-time within the bubble in a particular manner. However, this technique does not provide a warp drive that is capable of traveling faster than the speed of light. Lentz, on his own, has independently proposed a solution that does not necessitate the use of negative energy. He solved the equations of general relativity by taking a new geometric method, and as a result, he discovered that a warp drive wouldn't require the usage of negative energy at any point in the process. Because of Lentz's solution, the bubble would be able to move at a rate greater than the speed of light. For humans to travel between the stars, we must be able to move faster than the speed of light. Warp vehicles may be conceivable in the future, according to recent studies. That's all for this video. If you liked it, don't forget to like, share, and subscribe. And thanks for watching.